ఇప్పుడు మనం హ్యూమన్ ఐ అండ్ ద కలర్ఫుల్ వరల్డ్ అన్న చాప్టర్లో చాప్టర్ 11 చాప్టర్ నెంబర్ 11 of your CBSE textbook. We are looking into the scattering of light and Tyndall Effect point here. In order to explain you the concept clearly, I have presented a demo for you by taking 4 classes of different solutions, and through which, out of which 4 classes, the path of light is visible with a naked eye. We have seen the last demo. Why this is happening, why this scattering of light is happening is that the Earth atmosphere is completely filled with so many dust particles, water droplets, vapors, smoke, and different kinds of substances. Out of these abundant mixture, all the particles move here and there quite a number of times. They have freedom to move randomly as they wish. So while moving like that, so interplay of molecules with the objects coming in between them, it takes place. If we pass a beam of light through them, it gives us some spectacular phenomena. If, for example, you see when sunlight is passing through, this abundant mixture of vapors and dust, smoke, and all these particles, the sunlight passing through it gets scattered by different sizes of particles, which leads to a spectacular phenomenon of blueness of the sky and the redness of the sky at the sunrise and sunsetting times, and so many kinds of phenomena we have so many examples also we can give, just like aurora in some equators and equators region or poles region. You can see aurora in the sky, which is a very good concept for nature lovers. So beautiful this will be seen in the time. So the sunset and sunrise times we see the reddening of sun at horizon at the sunrise or sunset. This results because of scattering of light by colloidal particles. Colloidal particles means they are larger than the minute particles. Minute particles means we can't able to visualize the minute particles. So for example, ordinary water, if you take ordinary water, consists of dust, some minute particles. So that is why we are nowadays drinking mineral water or filtered water. In order to filter out the unnecessary particles, we are using this aquaguards and all. So ordinary water consists of smaller size particles we can't able to see. They will be inside that water solution. So here we have to consider 2 points. The path of light through a true solution is not visible. Path of light through a true solution is not visible. Here is the examples I have presented in the video. The path of light through mineral water we did not observe actually, and the other solution, salt water solution also, we did not come across that. and the remaining two, milky water, mixed milk water, and as well as dust, mud water, we have seen the light passing through. Because the size of the colloidal particles is a little bit larger than the normal situations. It is visible through a colloidal solution where the size of the particles is relatively large. Colloidal solutions, we can we can visualize the size of the particles. It will be equal. It will be somewhat larger in size when compared to two solutions. So based on this, Tyndall effect has been explained for us how this scattering is taking place. For which we are once again reminding you, Earth's atmosphere is a heterogeneous mixture of minute particles. Homogeneous and heterogeneous, two words we come across in chemistry parts. Homogeneous means of the same kind. Heterogeneous means of different kinds. For example, if we take some sugar particles, in which if some uh, other particles, just like groundnuts or someone is mixed in there, we can say that is a heterogeneous mixture. If we take purely sugar particles, then it is a homogeneous. If we mix a sugar in sugar, that is a homogeneous mixture. If you put some others, if you mix a salt in a sugar, that is different, heterogeneous mixture. So homogeneous mixture means of the same kind, heterogeneous mixture means of different kinds of particles. So Earth's atmosphere is a heterogeneous mixture of minute particles like smoke, water droplets, dust, and air molecules. Because we are living in the Earth's atmosphere, so the atmosphere around us consists of all these particles. We can't able to see, we can't able to visualize them actually by naked eye. We can visualize that if we go to some villages in villages, so many huts are there. People living in huts, poor people lives in huts. So in huts, a thatched house, huts, uh, there will be minute gaps in between the toddy leaves, so that the sunlight passes through those minute gaps inside the huts. So in huts, inside the hut, we can see a beam of light from the roof coming to the floor. If we look into the beam of light, we can see some smoke and dust particles are moving inside. So like that we can visualize, but through naked eye we can't able to see. We can't able to visualize the atmosphere, the quantity, the mixture of contaminants present in it, we can't able to see. When a beam of light strikes such particles, the path of beam comes visible. So when it is visible, if a beam of light strikes that colloidal particles, then only we can see the particles and all, what the movement and all we can see. The light reaches us after being reflected diffusely by these particles. So the particles, the dust particles, smoke, water droplets, and whatever the contents present in the atmosphere, they try to reflect this light diffusely in different directions, so that we can see the particles to some extent. The phenomenon of scattering of light, scattering of light by colloidal particles gives us Tyndall effect. Scattering of light, scattering of light by colloidal. Scattering of light by colloidal particles gives the Tyndall effect. So for which we are giving some examples here. Beam of sunlight enters through a smoke-filled room, like I explained you already. In a huts or thatched houses, we can see these kinds of experience, these kinds of examples. They comes true. We can see directly. And similarly, when sunlight passes through canopy in dense forest, and if you go to some dense forest, just like Nalamalai forest or Bandipura forest or whatever the forest, or nearby some thick plantation areas, we can see tiny water droplets in the mist scatter light. A mist means, smoke and mm, smoke and moisture both are mixed. So those the water droplets and mist scatter light. Hence, this color of scatter light depends on the size of the particles. I am reminding you these words since the beginning of this concept, that the color of scatter light, depends upon the size of the particles. It means that very, very minute size particles of the order of nanometer or picometer size particles, they reflect blue light. They reflect blue light. And the remaining colors, they are of different sizes, increase in size. That what I mean to say is large particles, large colloidal particles, large size colloidal particles, they reflect other wavelengths of light, just like violet, indigo, yellow, orange, and red. So all the remaining colors are being scattered by large size particles. Particles of large size scattered different wavelengths. So in the examination point of view, we should remember some 2 to 3 important concepts here in this scattering of light. First one is path of light through a true solution is not visible. Path of light through a true solution is not visible. Path of light is visible only through colloidal solutions. Okay? In the examination point of view, one question is frequently given, whether NaCl solution is true or colloidal. Okay, now can you see this? Whether NaCl solution is a true or colloidal means it is a purely true solution. NaCl, so that is why in the video of 4 glasses, I have mixed one salt in 1 glass of water. in which we didn't see any path of light, just like a mineral water glass. Okay, so this question has been given quite a number of times in CBSE or state syllabus. Hence, remember this. True solution, size of the particle is very small, and a colloidal solution, size of the particle is large. Sodium chloride, that is salt water, salt solution is a true solution because of this we can see we can be able to see the color of the water at 10,000 feet depth of Pacific and Atlantic oceans clearly. You can be able to understand this. And the other part we have to remember is scattering of light by colloidal particles gives Tyndall effect. Tyndall effect deals with the colloidal particles. Scattering of light by colloidal particles gives us Tyndall effect. And the color of the scattered light depends on the size of the particle. Microns, not microns, you consider nanometer size or picometer size particles are beyond the size of the particles. They scatter picometer and above, and less size particles they scatter blue light, and the other size particles they scatter the other different wavelengths of light. Now it's clear for you, I think. Thank you.